right, here we go. Okay, so this problem, we want to find the displacement at C, which is right here in the middle. And I actually have values for E and I. I don't know if we'll get to it in this problem, but you could actually do the integration, plug in E and I, and get a numerical answer. So to do virtual work, the first thing we have to do is write the moment expressions for the structure. So I would need a moment that's valid from A to B, and then a second one from B to D. So the first thing you probably want to do is find some reactions so that I can write my moment equations. So I'll use the drawing as my free body diagram to get started. So this will be AY, and I'll come over here and I'll say this is a reaction at D. I'll call it DY. Now a little planning to maybe save some time. I am going to cut the structure somewhere between A and B. And you're going to decide, am I going to work the left side or the right side? I think the left side's the best one to do. And when I do that, I will need AY. And then I'm going to cut it here, somewhere between B and D. And you have to decide, do I want to work the left side or the right side? I think the right side's easier, so I'll need dy. So in this case, I might need both of them. There may be situations where you won't need all the reactions, you'll just need a portion of them. So it's good to think through it for just a second, to plan what you need and to be more efficient in your calculations. So I'm going to need AY and dy. So first I'm just going to start by summing the moments. I'm going to do it at D. Make sure that's in equilibrium. And that will help me solve for AY. So this 16 kip force here at B, what kind of moment does that create with right-hand rule? Positive. So it'll be a positive moment. The force is 16 kips. The distance from D to B looks like 30. And then AY is the opposite direction, so that creates negative moment. The force is AY. The distance is 40. So it looks like AY is going to be 12. Does that sound right? And then it's pretty easy to then sum forces in the y direction. It's a pretty simple problem. So I'm going to assume up is positive. So both AY and DY act up. So that's AY plus DY. And then my 16 kips is down. That'll be negative. But I have AY. When you plug that in there, it looks like DY is 4 kips. Okay? So the first thing I'll do is I'll call this the real moments. So I want to find the real moment equations in this structure. So the first one will be valid just from A to B, which is, in our case, it will be from between 0 and 10. And when I cut my structure there, there's my little piece X between 0 and 10. And on the left edge is my AY reaction, which we've already found to be 12 kips. And then internally, all I'm looking for is the bending moment. As you can see, I assumed it's positive. So again, we'll sum moments at this cut that I just made. Make sure it's in equilibrium. And when I do that, I have the bending moment, which is positive. And this 12 kip force is creating negative moment. And has a moment arm of X. So that's pretty easy. It looks, the real moment is just 12X. So that's the moment expression for the first 10 feet. Not too bad. And really, you don't have any you only have one place to check it. I do know the moment at A. What is the moment at A? 0. And that's at X equals 0. And if you put in X equals 0, you do get 0. So at least it's satisfying that. The next equation I want to do would be from 10 to 40. And that's between B and D. We talked about that before. In this case, when I make that cut, it looks like the right-hand side would be easier. So I'll cut it. And the right side would be the reaction dy, and dy is 4. Of course, we're measuring everything from the left, so it'll be x up to the cut, and then the remaining segment would be how long? 40 minus x. And then again, at that cut, I'll assume a positive bending moment. So I'll do the same thing I did before. I'll sum moments now at the cut. Again, right-hand rule for my sign convention. When I look at this moment, even though it's a positive bending moment, my Stacks equation, it's going to come out to be a negative moment. And this reaction, the 4 kip, will be positive. So the force is 4 kips. And what's the distance? 40 minus x. So now you can solve for the moment. It might be easier to go ahead and multiply this out. Excuse me. So it looks like it's going to be 160 minus 4x. And that'll have the units of kip feet. I forgot this over here. This is also kip feet. And then we can check that. Where do I know the moment anywhere between B and D? Well, it looks like at D, which is 0. And of course, that's at x equal 40. You can look right here. If you put an x equal 40, this term cancels out. Same thing here. And one other thing you can check is they should have the same moment at the point they share 10. So I put in 10 here, I get 120. I put in 10 here, I get 120. So it looks like those two moment equations are valid. So I would do that kind of check as you go along, because everything in this problem kind of compounds and builds. If you don't get the reactions right, then you're not going to get your moments right. If you don't get your moments right, when you put them into the virtual work expression, you won't get the right answer. So up to now, these are skills we've done plenty of time. So the new thing now would be the virtual beam. And that would lead to virtual moments. So if I look at the same beam, the geometry is going to be the same. I'm still going to have a reaction at the left side, call it AY, and one at the left side, call it DY. Now, since I want to find the displacement at C, I'm going to apply a virtual force with no unit of value 1, where? At C, which is right in the middle. And which direction is it going to be, up or down? It can be anything you want, but if you do assume down, that you're assuming that that point's going to move down. And I would think that's a pretty good assumption looking up here. And what kind of displacement would that be in general, going down? Positive or negative? Negative. Remember, everything up is positive, everything down is negative. So I've already assumed down, so I'm going to get a positive answer, but it's actually going to be negative displacement. I don't care how you can do it either way you like. Some people like to always put a positive value here to keep the sign convention, but I'll easily look at your diagram, and if you assume down and get a positive value, then it's just down. Okay? This will be dimensions 20 and 20. So now I have to find the moments in this expression. How many do I need? Can I write 1?
Yeah.
Can I? I got a load right in the middle. So I'm going to have to write a moment expression that's good from A to the middle, and a second one that's from 20 to 40. So if I cut the structure here, what side do you want to work? Probably the left side. And when I cut the structure here, which side do you want to work? The right or the left? Probably the right. So I'm going to need both A and D in this system. How do I find the reactions at a beam with the load right in the middle of value 1? You can probably guess what they're going to be. They're probably going to be 1/2 and 1/2. But if you're not sure, then what do? Do what we always do. We're going to sum moments about some point, I'll pick D. Make sure it's equal to 0. And then about D, my unit load has a value of 1 and a moment arm of 20. And AY creates negative moment and a moment arm of 40. And you can easily see that AY is 1/2. It does not have a unit because our virtual load does not have a unit. And then quickly you can sum forces in the y direction. Both AY and DY are up, so they're positive. Our unit load is negative, acting down. So you can quickly see that DY is also 1/2. So I found my reactions. Now I just have to write moments. So my virtual moments, one will be between 0 and 20. That will be this cut here. We've already talked about it. The left-hand side probably is a good free body for that. So I'll look at the left side. My reaction on the left side is AY. In this case, AY is 1/2. And then my internal moment. Now remember, for virtual moments, we've been using the lowercase. So uppercase kind of indicates real quantities, in this case moment, and then the lowercase, the virtual quantities. So you just solve for that virtual moment. And that's not too bad to do. So if I sum moments at the cut, put it equal to 0, what do I have? Well, I have the internal moment, M is positive. My 1/2 creates negative moment with a moment arm of x. So it looks like my real moment is just x over 2. I'm sorry, my virtual moment. Well, does that work? We're looking in this range here from 0 to 20. Do I know the moment anywhere? Yeah, at A. A is a pin, so the moment at A should be 0, even in this virtual load case. And you can see you put an x equals 0, you do get 0 moment. So the next one would be between 20 and 40. That's this line. I'm cutting here. Again, you can work the whole left side or the whole right side. Looks like the whole right side is a little easier. So I'll do that. So there's the right-hand segment with dy. dy is 1/2. And this time we're cutting from the left, so here is x. So the right-hand side segment is going to be what? 40 minus x. And then internally I have a positive moment, but it's a virtual moment, so I'm using the lowercase here. And then something we've never done before. We're going to sum moments at the cut. So let's do that. I'm summing moments now at that cut I just created. In this case, when I look at it, this moment with my sign convention is negative. The 1/2 is a positive moment. So the force is 1/2 and the distance is 40 minus x. So my virtual moment now will be, you can run that 1/2 through if you like, and you get 20 minus x over 2. And where do you know the moment in this segment? Well, just like before, we know it at D. So that means at x equal 40, it should be 0. If you put in x equal 40, you get 0. And these two should match where? At x equal 20. All right? So you put in 20 here, you get 10. You put in 20 here, you get 10. So they match. So that seems like a good set too. So for my work, or for my, I guess, perspective, the hard work is done. So we just need to put it together into our virtual work statement. I didn't bring a piece of paper. Can I borrow? Does anybody have a piece of white paper I can borrow? You guys always seem to have white paper. Yeah. Thank you. Oh. You don't need your stinking. All right. So now I want the displacement at C. Remember, it's the integral from 0 to, this case, 40 of the real moment times the virtual moment divided by EI dx. That's the general statement. Okay? But you'll notice that in the real moments, I have one that's good from 0 to 10 and then a different one from 10 to 40. So I'm going to have to break up my integral at least from 0 to 10 and then from 10 to 40. Then you come down here and we have one that's good from 0 to 20, but then it changes from 20 to 40. So that means I'm going to have to break my integral up from 0 to 10 and then 10 to 20 and then 20 to 40. I break it up into 3 pieces. So the first one would be the integral from 0 to 10. And what is the real moment? 12x. What is the virtual moment from 0 to 10? Right here. X over 2. I should have taken my EI out, but I didn't, so I'll just have to carry it along now. Now what happens from 10 to 20? Well, my real moment changes, but my virtual moment does not. So this will become 10 to 20. Now I have a real moment equation that changes to 160 minus 4x, but my virtual moment is still x over 2. And then finally, from 20 to 40, real moment is this, virtual moment is that. You can see why this would be very tedious to pull off in class, especially on an exam. So this will be good enough for me. So there's the real moment, and then the virtual moment is 20 minus x over 2. Oh, and all of those, I forgot my dx here. Sorry. I'll put it back here. So there it is. That's the virtual work expression. So let's see if I can color code this to help you out a little bit. So remember, that's my real moment. See, it's a different value from 0 to 10. And then from 20 to 40, that's my real moment. On the other side, my virtual moment here is good from 0 to from 0 to 20, and then it's a different value here. Maybe I should have doubled them so you could see that they are different. So in this encoding, the purple is the real and the green is the virtual. And you can see here's my real moment from 0 to 10, and it's the same from 10 to 40. And then my virtual here and here are the same. That's from 0 to 20, and then it's different from 20 to 40. Now, if you had a problem like this on Master of Engineering, you still got a lot of work to do. Because now you have to do 3 integrations and then evaluate them at 3 points. Hopefully you won't make any mistakes. And then divide by E and I, and account for the change in unit, because all of our moments are in feet and our values are in inches. So there's still quite a lot of work to do. But for me, on the exam, you're done. For Mastering Engineering, you've still probably got 15 minutes of work to do. Now, a lot of times at this point, I cheat, and I just shove these into some mathematical program that will do the integrations for me, and I just write down the answer. You may do the same. However, on the exam, probably at this point, I might even allow you to finish the problem for bonus points. But again, the bonus points aren't going to save you. They're going to be bonus. That means you're done with the test. You think you're finished. Look at your watch. Hey, I got 10 minutes. Go do one of the bonuses. So that's the advantage. The advantage is it's not that bad. You can see you're writing fairly simple moment equations. But then when you get to this point, it becomes really tedious. Any questions about that? I think what I will do is I will go back to my office and I will do these integrations and show you the solutions and then put in the actual value E9, actually have a numerical value. I'll finish the problem for you so you can see it. But I'm not sure what Mastering Engineering will do, but I'm pretty sure they're going to want you to give them the value. So you'd have to pull that off. I will tell you this. When you guys took 20... Oh, I should probably stop this. You don't need this on the video anymore. Any questions before I stop the video?